Okay, we're going to finish up 4.6. So the first thing we need to talk about is complex conjugates. And remember the term conjugates from our square root lesson. It's the same idea here. So if we have the complex number, this is standard form. The conjugate of this would be a minus bi. And when we multiply two complex conjugates, we're always going to get a number for our answer. So it gives you the example of 2 plus 4i times the conjugate, which is 2 minus 4i. And we just FOIL like normal, so we'll get 4 minus 8i plus 8i and minus 4i squared. And we remember that 4 squared is 16 and I squared is a negative 1. And then our 8i and negative 8i cancel. So we're left with 4 minus 16 times negative 1, which is 4 plus 16, which is 20. And we'll continue to simplify, so we'll get 7 plus 33i plus 20, and I squared is negative 1, so 20 times negative 1. And in our denominator, our 4 i's canceled out, and we were left with 1 minus 16 times negative 1. Negative 1 again was I squared. In simplifying even further, in my numerator I had a 7 and a negative 21. So 7 minus 21 is negative 13. And I still have 33i. And then in my denominator, 1 minus a negative 16 would be 17. And the directions wanted it in standard form, so we need to write this in standard form. So we need the real part first, that would be negative 13 over 17. And then the imaginary part last. So we can break our denominator up and put 33i over 17. And this is my final answer in standard form. Here are 2 examples I would like you to try and put into standard form. Okay, welcome back. You should have gotten 5 halves minus 5 halves I. And for the second one, it should have been 11 thirteenths plus 16 thirteenths I. So just how we could plot points on our x and y axis, we can plot complex points on what's called the complex plane. So instead of a y-axis, we have an imaginary axis and we have a real axis. So if I had in standard form 5 plus 2i, that means I need to go positive 5 on the real axis, and then I would need to go positive 2 on the imaginary axis, and I would plot my point. So we'll plot letter A together. So I need to go 3 on the real axis, and it's a positive 3, so I need to go right 3. And I need to go negative 2 on the imaginary axis, so that would be down 2. And I would plot my point. Alright, I would like you to try the next 3 on your own. So for letter B, you should have went negative 2 on the real axis and up positive 4 on the imaginary axis and plotted the point. And for C, there is no real part, so the real part was 0 and the imaginary part was positive 3, so we need to go up 3, and that point's going to be on the imaginary axis. And then for D, we would need to go to the left 4 and down 3. So not too difficult. You just need to remember that the vertical axis is imaginary and the horizontal axis is real. So we remember that the definition of absolute value is the distance away from 0. So the absolute value of negative 2 would be 2. Same thing for positive 2. The absolute value of 2 is 2. Right, we're 2 places away from 0. So we want the absolute value of a complex number. Well, let's say we plotted our complex number. So this would be 2 plus 3i in standard form, right? We went 2 on the real axis and 3 on the imaginary axis. So if you remember from geometry, the Pythagorean theorem, that's what's going to come into play here. So I know 2 of my legs and I want to know my hypotenuse, because my hypotenuse is the distance from 0, or the origin, to my point. So when I find absolute value, I want the distance from the origin. And remember, our Pythagorean theorem is a squared plus b squared equals c squared, where c is our hypothesis, or hypotenuse. So c is the hypotenuse, and we know one leg is 2 and the other leg is 3. So if we square that, we should find our hypotenuse squared. And if we want to know our hypotenuse, we need to square root both sides. So we would get the square root of 2 squared plus 3 squared. So that's all this little key concept box is telling you. It's just telling you in general terms. So in general terms, if we had a standard form complex number, right, like I started with 2 plus 3i, now I just have standard form, and I want to find the absolute value of it. So the absolute value of this, let's say this standard form is z. So the absolute value of z will be the square root of a squared plus b squared. So it wants me to find the absolute value of negative 4 plus 3i. So using what we know the absolute value is going to be the square root of a squared plus b squared. A in this example is my real number and b is my imaginary number. So I would have negative 4 squared plus 3 squared. And then I would get the square root of 16 plus 9, which equals the square root of 25, which equals 5. Now I would like you to find the absolute value of negative 3i. So you should be able to see that the real number is 0, right? There's no real number, and our imaginary number is negative 3i. So if we want to find the absolute value, that's going to be the square root of 0 squared plus negative 3 squared. And then we would get the square root of 9, which equals 3. So I would like you to plot these 2 points on the same complex plane and then find the absolute value of each complex number. And you should have gotten this as your answer. So that's the end of section 4.6, and come ready to practice.